This is Chapter 4, Part 2. Section 4.4 is indeterminate forms and L'Hopital's rule. So really quick, this is on Unit 3 now, so on our third exam. First thing says, we discussed limits at the very beginning of the semester. Let's quickly review limits. And just really quick too, I sketched in a few graphs. I sketched in tangent of x and also the natural log. So first thing is the limit as x approaches infinity, f2 over x. So as x goes off to infinity, this is going to become 2 over something really, really big, which is going to be something really, really small, practically 0. The next one says 2 over x coming in from the right. So we would have 2 over 0. And if you're approaching 0 on the right side, that is a positive 0. And so this is going to be positive infinity. The limit as x approaches 0 on the right, if you look at the graph up here, this is going down to negative infinity. As we approach pi over 2 on the right of tangent of x, again the graph is down here, you are also, as it goes to negative, as you approach pi over 2 on the right side of it, that is also going off to negative infinity. As the limit as x approaches infinity of the square root of x would be infinity. And then the limit as x approaches 0 of sine of x is just 0. Again, if you need to, you can look at the graph of that. So the next thing we had, and I had a few of you guys asking about this earlier in the semester, about L'Hopital's rule, and when I said we can't use it yet, we haven't learned it. So now we're actually learning it. So L'Hopital's rule says if f of x divided by g of x is an indeterminate form, which means you're going to either have 0 over 0, or positive infinity over positive infinity, or negative infinity over positive or negative infinity. And it works whenever you have x is approaching a or x is approaching positive or negative infinity. Then, and this works again for both, the limit as x approaches either a or plus or minus infinity of f of x over g of x, if we get indeterminate form, we're able to take the derivative of the numerator and the derivative of the denominator, and the limit of that is going to be the same thing as the limit of the original functions. So you need to realize we're not using the quotient rule. We're actually just taking the derivative of each one individually. So it says, informally, L'Hopital's rule states that if the direct substitution results in any indeterminate form, take the derivative of the numerator and the derivative of the denominator separately. Do not use the quotient rule, and then evaluate the limit again. So note, L'Hopital's rule also applies to one-sided limits as well. If you're looking at this one says as x approaches 0 from the right. To symbolize the L'Hopital's rule, we're going to put an LH above our equal sign. So that way you're communicating with me that that's what you're doing. And then also the textbook will do that. It's very standard. You will notice little LHs above everything else, or an H. First example here says find the limit. Use L'Hopital's rule when appropriate. If there is a more elementary method, consider using it. If L'Hopital's rule does not apply, explain why. So for this one, the first thing we're going to do is just direct sub. If you substitute in 1, you're going to get 0 over 0, which is indeterminate. And it's of that form that we can use L'Hopital's. So I'm going to go ahead and I'm going to rewrite the problem that we have. And then we'll use L'Hopital's. So let's rewrite the problem. It's limit as x approaches 1 of x cubed minus 1 over x minus 1 equals, and I'm going to use L'Hopital's rule. Another way to do this would have been factoring the numerator using difference of cubes. Since I'm using L'Hopital's, I'm going to go ahead and put an LH above it. The limit still stays the same, but we take the derivative of the numerator, and the derivative of the numerator is going to be 3x squared. And the derivative of the denominator is just 1. So again, we took the derivative of the numerator and got 3x squared, and the derivative of the denominator and got 1. So we're going to try direct sub again, And if we do direct sub, we're going to have 3 times 1 squared divided by 1. And this is just going to work out to being 3. So again, L'Hopital's worked because we had 0 over 0, which was of the indeterminate form that it needs to be in order to use L'Hopital's. So we're going to leave B to go through together, but let's take a look at C. Same rules, same direction. So it says the limit of this. So we would have, substituting in infinity, you would have infinity over infinity, which is still indeterminate. And since we have an indeterminate form of this, infinity over infinity, we're able to use L'Hopital's again. So I'm going to go ahead and rewrite our function and our limit. So we have the limit as x approaches infinity of x squared minus 1 over 3x squared plus 3x. And we're going to go ahead and use the L'Hopital's. Put an LH above that, and your limit stays the same. Derivative of the numerator is going to be 2x, and the derivative of the denominator is going to be 6x plus 3. So we're going to try to use direct sub again. 2 times infinity would be infinity over 6 times infinity plus 3 is still infinity, which is still indeterminate. So yes, we need to use L'Hopital's again. So sometimes you have to use L'Hopital's multiple times in order to arrive at your answer. Again, you could have tried to factor this one to see if it works, and it could. There's multiple ways to do these and still be okay. So this is L'Hopital's, is the limit as x approaches infinity of, taking the derivative of our numerator, it is just 2, and the derivative of our denominator is just 6. And so the limit's a constant, that just simplifies to 1/3. And that is the limit that we get. So again, both of these that we've done, you could have been able to factor them both and simplified it. That would have also worked. So let's take a look at D. So for D, if you were to substitute in your values, you get 1 squared minus 1, which is 0, over 1 squared, which is 1 minus 4. So this works out to being 0 over negative 3. But 0 over negative 3 is not indeterminate. This is just 0. So this one you don't need to use L'Hopital's rule. So you're able to evaluate that limit just directly. So be careful because you're going to have those on your homework too, and don't assume that all the limits are going to require you guys to use L'Hopital's rule. Okay, on to the next page. E, we will look at together. My suggestion is to refresh yourself about what the graph of secant of x looks like so you understand what's going on and what tangent of x looks like. And we have F. So F says the limit as x approaches infinity of ln of x divided by 2 times the square root of x. So the graph of ln of x is on the first page, and as that approaches infinity, the n goes off to infinity, and the denominator would also be infinity. So this is indeterminate, and we are able to use L'Hopital's rule. This is a good problem because you cannot simplify this in order to reduce this. We would have been stuck before and had to make a table or something along those lines, or look at the graph. So I'm just rewriting the problem. I'm going to put equals and put down L'Hopital's. Same limit as x approaches infinity. Derivative of the numerator, the derivative of ln of x is just 1 over x. And the derivative of 2 times the square root of x is going to be 2 times 1/2 times x to the negative 1/2. And again, rewrite that with an exponent rather than a root, and maybe that would help if you're stuck. From here, you need to simplify this. So I'm going to simplify my 2's, and I am now at the limit as x approaches infinity of 1 over x all over 1 over the square root of x. So a lot of different ways to deal with this. You can multiply by the reciprocal. I'm just going to multiply both the top and the bottom by the same thing, and I'm going to multiply by rad x. So your rad x here's are going to cancel. And then we have the limit as x approaches infinity of, and then x, square root of x divided by x is going to simplify to just being 1 over the square root of x. And taking the limit of 1 over, subbing in infinity, 1 over something really, really big is going to be something really, really small, so pretty much 0. And that is your answer. So down at the bottom, it says important to use L'Hopital's rule. You need one quotient or fraction, if you want to think of it that way. And it says sometimes we can use algebra to convert limits of types of indeterminate form like infinity times 0 or infinity minus infinity into these forms that we can use L'Hopital's rule. So this is definitely something that we need to know. So give that a start.